Week 7, Task 2 over geometric sequences. So remember, a sequence is a list of numbers or objects that are in a special order. In Task 1, we talked about arithmetic sequences that happen when things are being added to a number before it every time. This lesson is going to be about geometric sequences where they have a common ratio. So the difference is arithmetic is a common difference. Geometric is a ratio. So difference meaning add or subtract, ratio meaning multiply or divide. So in this, vocab is very similar. A to the n is the nth term. A to the 1 would be the first term. N is my term number, and D is my common ratio. So this vocab is very similar to what we saw in week 7, task 1. I'm not going to go over that, so if you haven't watched that video, go watch that one before this one. My formula for geometric sequences is going to be my start, or my A to the 0, times my rate, so my common difference, raised to the n or x minus 1. Okay, now the reason it's n minus 1 is because it is an exponential function. So you can't have a, you can have a 0 term, but you can't have a -1 term. So you need to make sure you see that your terms are going to be listed just a slight bit different. So example 1 wants us to write the first 5 terms of a geometric sequence with a first term of 2. So I have that number 2 right there, where each consecutive term is 4 times the previous. So 2 times 4 would be 8. 8 times 4 would be 32. 32 times 4 would be 128. And 128 times 4 would be 512. My common ratio is 4 times the previous, so my common ratio is going to be 4. Example 2 asks for the common difference of the sequence given below. So when you're finding the ratio, you want to take the term in front and divide it by the term that came before it, so it's previous term. So to find my ratio, and I'll write it over here, you take term 2 divided by term 1. So 27 divided, 27 divided by 81, and then turn that into a fraction, so that common ratio is going to be 1/3. It does not matter which 2 terms you use, as long as you use 2 that are right next to each other. So if I use 9 divided by the term that came before it, I get the same thing. 3 divided by the term that came before it, I get the same thing. Now again, it always has to be the term before, because remember, in a sequence the order matters. So if I were to continue the sequence, I would need to find a to the 7. So this time my first term is that first number. My common ratio is 1/3, and then remember it's x or n minus 1. So in my calculator, I would do 81 times 1/3 raised to the 7 minus 1. So 81 times 1/3 raised to the 6. And that's going to give me an ugly fraction, so math inner would be 1/9. Now, I know you might be thinking on your phone calculator you don't have those ugly fractions to turn into, or ugly decimals, you can't turn them into fractions, but on the assessment there won't be any with these ugly fractions. We're doing them in the notes so you can see it, because most of the time our numbers are not pretty, but just want to make sure you are aware that there will not be any ugly fractions on your assessments. So example 3, a sequence can be generated using a to the n is 5 times a to the n minus 1, where a to the 1 is 2. What are the first 4 terms in the sequence? So a to the 1 is my starting, okay, so that's where I'm going to start this value. This 5 is going to be my D, or my common ratio. So 2 times 5 is going to be 10, times 5 is going to be 50, times 5 is going to be 250. If I wanted to write my function, it would be my starting times my rate to the x or n minus 1. Example 4, write the formula for the nth term of the sequence given below. So my common ratio, remember I take a value, divide it by the value that came before it. So 6 divided by 2, because that's the number before, my common ratio is going to be 3. I could also do 18 divided by the number that came before it, or 54 divided by the number that came before it. If you are asked if it is a geometric function, then you would need to make sure all of these are divided by that same ratio, or multiplied in this case. So my formula is going to be my starting value times my common ratio raised to the x, or n, minus 1. So for the last few problems, the common ratio, given that sequence 10, 20, 40, 80, you might be able to see it, but a number divided by the number that came before it, 20 divided by 10, would be 2. Just like 40 divided by 20 would be 2, and 80 divided by 40 would be 2. A to the 1 is 10. That is my first term. So my formula is going to be 10 times 2 raised to the x minus 1. Then to use that formula for the 10th term, I would do 10 times 2 raised to the, oh, I lost my mouse. Okay. Raised to the 10 minus 1 would be 9. You can also, if you have a graphing calculator, you can type in 10 minus 1 and you get 5120. Now I want to show you very quickly on your calculator on a phone how you would do that, and then I will continue with the last parts. So on a phone calculator, if I were trying to do this one, 10 times 2 raised to the 10 minus 1, I would want to put in as little as possible, okay? So I would want to first figure out that 10 minus 1, which is 9. Then I would do 2. Notice I've turned my phone sideways to get that extended view. This button right here, your x to the y, is what you want to type to get an exponent. You want to click equals and then multiply by that number in front to get your final answer. So I'll show you on the next one as well, just in case you missed it. But remember, you can always pause and go back and watch that part again. So common difference here, 15 divided by negative 5 is going to be negative 3. In the same way, negative 45 divided by 15 is also negative 3. Formula is going to be negative 5 times negative 3 raised to the x minus 1. So using this formula, negative 5 times negative 3 to find 5. So we're really going to type negative 5 times negative 3 to the 4. So on my phone calculator, because I'm assuming you know how to put this in on a graphing calculator, I turn my phone sideways to get that extended menu. So 3 as a negative being raised to the 4 is 81 times 5 as a negative to get negative 405. Okay, so just make sure you turn your phone sideways and use that little x to the y button if you need an exponent. If you were plugging this into your graphing calculator, fairly straightforward, and you would get negative 405. So for the last one, example 7, given the first term and the common ratio, find the first 5 terms and the formula. That formula is very quick and simple. This is my starting, this is my rate raised to the x minus 1. So as long as you remember it's always start times rate to the x minus 1, then you'll be good to go. So the first 5 terms, we have 2 times 3 is 6, times 3 is 18, times 3 is 54, and then times 3 is 162. Now, if you have a graphing calculator at home, you are more than welcome to put your formula into your y equals, exactly like you see it, x minus 1 included. Go to the table and then write down your first term is 1, second term is 6, third term is 18, fourth term is 54, fifth term is 162. But again, I just showed you how you could do it if you have just a basic calculator. You can just do 2 times 3 times 3 times 3 times 3 to get all of your different terms.